Hi everyone, it's Kathi from Isodrones. In this video we want to show you a method test we conducted. In my PhD I work a lot with stable isotopes of tree water. This allows us to investigate which soil water trees use. So for example, if they take up water from soil close to the surface, or if they use deep soil water, or even have access to groundwater. In the experiments we conducted so far, this was quite a complicated setup, and it took a lot of planning and time to install everything, and also quite some material that one has to buy and also have the funding for. Two colleagues and friends of mine and myself teamed up to test an easy, low-budget kind of DIY version of that method. I know that what we do looks a little bit brutal. However, taking an increment core from wood tissue is a normal sampling method in our field and usually does not impact trees too much. Additionally, the new method we are testing allows to sample repeatedly from the same hole, while multiple cores are often extracted with traditional approaches. Hi guys! So I went to the forest with Ruth and Angelika today. First step, drill a hole. We use a manual corer because we don't want the wood to heat up a lot. If we drill holes this way, we can also take a sample right away that we can use to validate our new method. And we have to be really fast with this because we want to prevent evaporation and therefore isotopic fractionation as much as somehow possible. After drilling of each hole, we cleaned the core and the thing to extract the core with. This is the PFA tube that we're going to install into the borehole that we just drilled. We're going to fix it by filling the outer part of the borehole with silicon. We have to let that dry for 24 hours before measuring. So we are back in the forest, and today we're trying to measure the holes that we drill and collect some water vapor samples. So this is how we take a sample with this setup. There is a tiny pump. We use the voltage regulator to adjust the flow. Then air is pumped through the tube into the desiccant tower, which removes water molecules from ambient air. The now dry air comes out from the other side of the tower and flows into the tree hole. Inside the tree, it takes up water molecules, and then the moist air flows out from this side and we collect it in this bag. This is one of the bags. And then the air that is inside the bag with the water vapor that we sampled is gonna be sucked into the analyzer with this tube. So just now you saw the composition of the lab air, and now you see that it changes, and that's the air that was sampled inside the bag. We compared the analyzed bag measurements with values from an established approach. Unfortunately, measurements with our new method systematically deviated. So we racked our brains for possible explanations, and one idea was that something inside the coffee bags could change the isotope value of the water vapor inside. So I conducted another experiment testing exactly that. And this is my setup. So I have this container, which I found in the institute, super practical. It has a small fan that mixes the air inside. And I put this plastic container with a water source, and the water is evaporating from there. And here is a pump I can regulate with a voltage regulator, and this sucks out the air in this box, and it flows into this tube. And here I can either connect the tube directly to our water isotope analyzer, or I can connect a coffee bag and sample into the coffee bag. So I can compare the signal that is inside directly with the one I measure from the coffee bag. And this is what the measurements look like. After quite a few different tests I conducted, it turned out that completely new bags indeed changed the measured isotope signal, most likely due to spectral interferences of emitted organic compounds. So in order to use them, one has to properly ventilate them beforehand, or even better, place them inside a drying oven overnight. As so many times in science, you wonder why you've not thought about this beforehand. But well, afterwards you're always smarter. So I hope you had fun. That was it from me, from the lab. I guess watching it for like 10 minutes might be super interesting and cool, but doing it for 3 days straight at some point, you just want to get done with it and go outside, see the sunlight. But yeah, I wish you a good time and see you soon.